Okay, so I want to do problem 7. F of x is equal to x e to the minus x squared. And so A is classify this function, and this is a product of a linear function and an exponential function. Right, and now, so a couple things, I might try and, a lot of times I do try and think about what these look like. This linear function, x, and because some of these properties can convey or give you insight into the combined function. So here's this function x. One of the things here is that it's odd, right? But it's this linear function. I also know that it has lower growth power than e to the x. Now, e to the x, I want to draw this, right? So e to the minus x looks like this. Okay, so it's this function, it's exponential decay. Now, the question is, what does this x squared do to this function? And really, I might think of this function as 1 over e to the x squared. And really what this x squared does, one of the things that it does is it makes this particular part of the function symmetric about the y-axis. So for sure when I'm thinking, like let's say I think that it looks like this, right? Except that it's symmetric, so I know that this left side should be in the same, like should look the same as the right side, which kind of makes it feel weird. Like I might not get, for sure, as x gets really big, this is going to 0. But then on the other side, now when x gets really negative, it's also going to 0 because I square that, right? And I'm dividing by this really big thing. So then kind of what's happening, I don't know what's happening in here, but I know that it looks the same on the left and right. Okay, so one of the things I just noticed even in this moment is that this function, and that I'll write down where we talk about anything else, h, but I noticed that this should be an odd function. Right? Okay, so this should be symmetric, the whole thing, because x is odd and I'm multiplying it by this even function. This whole thing should be odd. So I will get, that will help me kind of do the analysis if I just understand the symmetry and how it will convey either side. Okay, so the domain here should be minus infinity to infinity. I don't have any values that are disallowed for x. The end behavior, let's take a look at this. Limit as x goes to infinity of x e to the minus x squared. And if I just try to kind of blindly think about what's happening, this x piece is going to infinity and the e to the x piece, e to the minus x squared, is going to 0 because x will get really big. So this is an indeterminate form, and I need to turn this into a form that I can use L'Hopital's on. So that looks like this, because now this form is infinity over infinity, right? So I can take the derivative of this. So I have limit as x goes to infinity of 1 over 2x e to the x squared. And that should be going to 1 over infinity, right? Which really goes to 0. Okay, so I know that this is going to 0. Let me check this real quick. Okay. I know that this is going to 0. So then I also actually, oh, gracious. I know that on the negative side, by similar reasoning, as going to 0, if only because this is an odd function, so it has to be symmetric about the origin. So maybe one side is going to 0 from the top and one is from the bottom, but like there's no way to get around this kind of limiting value. Okay. And even if you just plug in large negative values into this piece, you'll kind of see it's getting closer and closer to 0, but the x values will all be negative, so it might just float right under. In my head, I'm having this picture. It might just float right under the x-axis. Okay. So part D, any asymptotes are whole. So because these two functions, one of them is exponential, I expect this horizontal asymptote that I found with this limiting behavior. So horizontal asymptote of y is equal to 0 on both sides. But I don't expect a vertical asymptote. There are no problems in the domain. So I'm going to put no vertical asymptote or holes for my conclusion there. Okay. Intercepts. So f of x is what again? X e to the minus x squared. So when I set that equal to 0, I just get x is 0. This e to the minus x squared will never be 0. It's a positive number raised to a power. That can never equal 0. And then f of 0 is also 0. So I have one intercept. It's at 0, 0. Okay, intervals of increasing, decreasing. So f prime of x, product rule, right? So x times e to the minus x squared. Do I take the derivative of either one of those? No. Okay, let's try this again. F prime, let's do 1 e to the minus x squared plus x times, and then it's a negative 2x e to the minus x squared, I think. So when I factor out this e to the minus x squared, I'm left with 1 minus 2x squared. Is that right? So I get e to the minus x squared. Oh, I don't need to rewrite this. I just need to set these equal to 0. Well, e to the minus x squared is never equal to 0, so that leads nowhere. 1 minus 2x squared is equal to 0. I don't need this parentheses. So 1 is equal to 2x squared. 1/2 is equal to x squared. And x is equal to, this is the square root of 2 over 2. Okay. Which is the same thing as just the square root of 1/2. Once you rationalize this denominator. Okay, so, and I need a plus or minus here, because this is, okay. So then I'll have negative square root of 2 over 2, and positive square root of 2 over 2. And that, again, makes sense because I expect this function to be odd. So I expect there to be symmetry all along the way here. So like these things where like I'll have a max on one side, I'll have a min on the other. So I have, I'm going to, like this is from minus infinity to minus square root of 2 over 2. Minus square root of 2 over 2 to square root of 2 over 2. And then square root of 2 over 2 to infinity, right? Okay. And so my test point in here, I do not know what the square root of 2. Oh, that's about 0.6, is that right? Because square root of 2 is about 1.2. Sorry, my brain is about to die. Square root of 2. So I'm going to check on the calculator. Oh, 0.7. Okay, so this is about 0.7. Negative 0.7. Just for kind of surety. So I'm going to plug in, and this is a negative, so I'll go and plug in negative 1. Here I'll plug in 0, or negative 2 and 2, right? So these are my test points. F prime at my test point. So where is my derivative again? Oh, there it is. Okay. And again, I'm going to use, like, I cannot emphasize this enough, this factored form of my derivative to figure out what the sign is here. Okay? So e to the minus x squared, this piece, so I want to talk about these. So here's this derivative. I'm going to write this. Good. So e to the minus x squared. E is a positive number. When I raise it to anything, it will always be positive. So this piece is always positive. And I really just need to figure out the inside piece, right? 1 minus 2 times x squared, right? So now when I plug in negative 2, it's 1 minus 2 times 4. So that should be a negative. When I plug in 0, that should be positive. And when I plug in 2, again, that should be negative. Again, I expect pretty much the same value to come out of this. Like I'm looking for kind of this odd behavior, right? A behavior of an odd function. Okay, so I have and this sort of result here. Sorry, my brain really is dying. Like this, so I have a min here and a max here. Okay, so then I want to do, that's part F, and then I want to do this part G. For this second, I should probably write these conclusions for F, so let's write this down. So f of x is decreasing. I didn't do this yet, right? On minus infinity minus square root of 2 over 2 union square root of 2 over 2 to infinity. F of x is increasing on minus square root of 2 over 2 to square root of 2 over 2. Then I have a min. F of x has a min of, and then f of square root of 2 over 2 should be, I think, 0.4288. And f of, oops, that's the negative one, and this one is negative. F of x has a max of, and then because it's odd, 0.4288. Oh, wait, I'm going to put x is equal to negative square root of 2 over 2 at x is equal to square root of 2 over 2. Okay? Okay. And then part G, I have the second derivative test, right? So my first derivative is e to the minus x squared, 1 minus 2x squared. And the second derivative of f of x. Actually, I'm going to just maybe, I am going to re-multiply this out and then just do 2x squared. I'm going to do the derivative like this. And I mean, you could do the product rule in its original form. I would just say, I'm going to do it like this. So I get negative 2x e to the minus x squared. And then here's my product rule that I'm going to do in parentheses here behind this minus sign. So I'm going to do, and this is, so let's do 4x, right? E to the minus x squared, f prime g, plus g, or f, g prime, which is negative 2x, e to the minus x squared. Right? Okay, and then I'm going to simplify this. Negative 2x squared. let's see, minus 4x e to the minus x squared minus 4x cubed e to the minus x squared. I think that's what I have, right? Okay. So then I get a negative 6x e to the minus x squared minus 4x cubed e to the minus x squared. And then I'm going to factor this. I'm going to take out negative 2x e to the minus x squared. And then what I'm left with is, 3. I think it's just 3 there, right? And then plus 2x squared. And then where this is 0, so I have 3 different pieces. That piece, this piece, and this piece. So this piece, negative 2x is equal to 0, gives me x is equal to 0. This piece, e to the minus x squared equal to 0, gives me nothing. This is never equal to 0, so no critical values or hypercritical values from there. And then 3 plus 2x squared. Did something go wrong here? I have a minus in my notes. I'm going to look at this real quick. Oh, can we look back here? So this is a minus and this is a negative, so this should be a positive. Can we fix this? So then this here should be a negative. Okay, so I'm going to put that in. That's right. Okay. So then I get 3 is equal to 2x squared. 3 halves is equal to x squared, and plus or minus the square root of 3 halves is equal to x. And then if you're using a calculator, I'm not going to rationalize that. I'm just going to go ahead and get this as plus or minus, and then these values are about approximately 1.225, right? Okay, so then I have these 3 values. So I have minus 1.225, and again, it makes me feel good that I have these kind of paired values on either side because of the oddness of this function. And then I need to test this. Now I'm going to use, okay, so this is perfect. I'm going to use this second derivative in this form. And actually, I might rewrite it. I'm going to use it in a slightly different form. I'm going to switch around the e to the minus x squared and put that here. And then I have an x piece. And then I have a 3 to the minus 2x squared. Okay. Now, this piece is always negative no matter what I plug in, because the e to the x piece, e to the minus x squared, is always positive, and this negative 2 is always negative. So I really just need to fill in what these are for each point. And then I can figure out what the sign of this is. So I'm going to plug in negative 2 here, negative 1, 1, and 2. Okay? So at negative 2, my 3 parentheses look like this. Negative. And then this, the second one, just x is negative. And then the last one, 3 minus 2 times negative 2 squared. So that's 3 minus 8. That also should be negative, right? So I get a total of a negative here. Okay, so now negative 1. I have a negative, that's always negative. Negative x is, or negative 1 when I plug into x is negative. But when I plug negative 1 into this last one, this should be positive. So this is a positive. Okay, this first parentheses is always negative. This parentheses now is positive, and then when I plug 1 in here, it's also positive. So this piece is negative, and then the final one, negative. When I plug in 2, it's positive. When I plug in 2 in the last piece, it's negative. So I get positive, okay? Which means I have points of inflection, 3 different points of inflection here. Okay. So I'll write these. There's a couple things. So I want to say, I plugged in f of square root of 3. It's this one. Square root of 3 over 2. And I got that was 0.273. And likewise for the negative, because of oddness, it's the negative value. And at 0, f of 0 should just be 0. Okay, so I have these conclusions. F of x is concave down on minus infinity to square root of 3 over 2 union, and then it's 0 to this one is negative, to positive square root of 3 over 2. F of x is concave up on negative square root of 3 over 2 to 0 union the square root of 3 over 2 to infinity. F of x has points of inflection at, and then I'm going to list these points. Square root of 3 over 2, 0.273, 0, 0, and then negative square root of 3 over 2, negative 0.273. Okay? Okay. And then here in this part for h, you should talk about how that this is an odd function. And I kind of did that up at the beginning, but this is a great place to talk about doing the test for oddness, because it's so important in this problem that is true. Okay, and so in I'm just going to write down, but I feel like I've been talking about it for like 50 minutes. So I'm going to write down all of the information that I have. And kind of the values. So I'm going to maybe backtrack. I'll write down these three. Oh, this is a 2 right there. I'm going to write down these 3 points. So, and I'm going to put in the decimal values for this square root of 3 over 2 because I just kind of want to know about how big these are. So negative 1.225, negative 0.273, I have a 0, 0. Right? And then I have this concave up. I might just draw this line instead of writing this all out. So I have this one, and I have minus. And this is, so I might, because this is just shorthand for myself. I mean, all this stuff in I is just stuff I use to substantiate the scale that I'm using and think about the scale. Okay, so I'm going to put in this concavity information, which was down, up, okay. And then these were points, all points of inflection. And then the rest of the information from above that I have is, let's see. So I have this from the increasing, decreasing. So the increasing, decreasing looked like I had these values at minus square root of 2 over 2, and then square root of 2 over 2, right? And it looked like this, decreasing, increasing, decreasing. And then I'm going to put this max min. So there was a min at negative square root of 2 over 2 of negative 0.4288 min. And it's square root of 2 over 2 at 0.4288. That's a max. And then 0, 0 was the intercept. And then I have a horizontal asymptote at y is equal to 0, right? Okay, so this is kind of the information that I need to put on this graph. But one of the things, especially from scale, and like I want to get an estimate for this square root of 2 over 2, which is really 0.71. Approximations, then then if you look here, the scale are really, I mean, like everything is happening between, like on the x-axis, between -2 and 2, for sure, and on the y-axis between -1 and 1. And so most of this stuff here, because of the small scale, I need to really expand that. So for example, I don't want to draw, I'll put this down, but I don't want to draw kind of the normal gridding. Like I don't want to make this 1 and this 1. Like everything is going to be like almost in this little box, right? So I want to spread this out quite a bit to see what's happening. And so I might do this by, I just need to go to 2 mostly. 1, 2, 3, 4. So I might do something like this. 1, 2, 3, 4. And make every one of these like little griddings quarter. So really like this is 1, and then this would be, and I won't write all of these in halves, but this is 1, 2, 3, 4. No, that's a -1, -2, -3. Okay. So we have kind of this sort of gridding that might be okay, right? Okay, so then I have this horizontal asymptote. Y is equal to 0. Again, the x-intercept is 0, 0, which is not it's not a problem for these to cross the horizontal asymptote. Then I'm going to put the rest of these points in. So -1 it's almost -1.25, right? Yeah, so I'm going to put that here, and the y value is negative. So maybe I'm going to ballpark it right there. Then the other one on the other side. And then, let's see. 0, 0 is still there, but it's also a point of inflection. And then the min negative, like this is -0.75 and -0.4, so I might put it right in here. And then 0.71 and 0.4 right there. So that's a max. This is a min. Even here, I don't feel like I've spread this thing out enough. If I had to do it again, I would. So then I have concave down here, concave up here, and then it changes at these points of inflection. So like from this point here, it's concave down. So I want to something like this. From this point here, it's concave up. So it looks like this. So I probably should have even made the y-axis, if I look back on it, even more spread out to kind of maximize these distances between things. But I think it's okay. So like I have here is the max. This is a point of inflection. This is a point of inflection. This is a min. Here's another point of inflection. And some of y'all have been labeling these like this, and I think it actually looks okay and kind of looks nice. It draws attention to these changes in concavity, and then I'll make sure that I'm matching this increasing, decreasing, like there's decreasing, increasing, yep, and then again decreasing. Is this okay? And you see the odd, this odd symmetry too.